This video will be about iPhone charger 5 volts, and next video will be to hack this module. What is this module? It is very interesting. As you can see, we have here LEDs that are synchronized with the motor. I bought this on Greece because it is very nice, and I had to understand how this is working. So I will also do a reverse engineering in order to find the way that these LEDs are synchronized and enabling this very nice writing. As you can see, I love Greece and I love words. Okay, thank you. Hi. So I have here this iPhone charger. I'm not sure if this is OEM or the original one, but I want to look at the design and to understand if it is a good design and safe for use. Okay, so this is the original case, and it was very hard to remove it from the case. I had to use Dremel for this one. So if it is like this, so it is better, and I can know that it will not break apart easily. So let's look at the design to understand if it is good or not. So if I'm looking at this design, I can see that generally it looks quite good design. Why is that? Because this is the input of the 220 volt and this is the output of the 5 volts. I can see that I have here a PCB gap without any traces. The gap is about, I think, 6 or 7 millimeters, and this is good because if I will have breakdown in this area of the 220 volt, so the spark and anything that will happen will not get to the other side, which is the low voltage. And also there are some other facts that will prevent this failure. I have here an optocoupler that it is a feedback from the 5 volt back to the controller, and also I have looked at the datasheet, and also it is isolated for kilovolt, which is very good isolation. Also I can see here that other things, looks that it is not a cheap one. I have here coils. The reason for these coils usually is to remove RFI radio frequency interface from the DC to DC to the output of the outlet, and this is done by this coil that filter in the high frequencies. Also I have here something that looks to me like fuse, and this is always a good thing, because if I have some spike that can cause this circuit to stop working, if it will be a short here, so the fuse will blow and prevent current to flow to this circuit. Also I have looked at this ST component, which is a FET, and so they are using a DC to DC in order to lower the voltage. Basically all this kind of power supplies work like this. You take the outlet voltage, you use a bridge rectifier in order to make it high voltage using these capacitors, and later you're using a DC to DC with a PWM. You're using a PWM in order to switch this MOSFET. This MOSFET is driving probably this coil, and then you are lowering the voltage. Okay, so I can see here the isolation, and the parts that are being used are basically good one, because for example this MOSFET is for 600 volt peak, which is much better than the highest voltage that should be here. So this is a good thing. Also the isolation here and all the parts are glued in order to make sure that if it will fall down, the parts will not move away and will be able to create a short circuit. So this design is quite good one. This rubber, I guess it is some kind of rubber that is using also to remove RFI interface, because we have here I don't know what it is. It is a diode, so I guess that it is all maybe to cool the diode or to prevent also RFI interface from the diode outside, because probably this is using a little conductive on the edge in order to prevent RF frequencies to go to the outside. Okay, this is for now. So basically, if you are deciding to buy a few charger, the best thing to do is to break one of them and look at the design, and by the design to see if it is safe to use or unsafe to use. Unsafe, for example, if you don't have fuse and you don't have a gap between the high voltage and the low voltage, and the components are cheap Chinese and not known companies like ST that is using this MOSFET. So it is a good thing to try to reverse engineering these products before using fuse them, and decide if it is safe enough to connect them and use them. Thank you.